everyone, Tina here, and today I'd like to talk about conditional probability. This is when you have to answer probability questions about events that are dependent on each other. The probabilities can change as you go through the question. You'll need to be familiar with this idea if you're doing the Higher GCSE course. In this video, I'll talk through a couple of examples of conditional probability, one using a tree diagram and the other one using a Venn diagram. I've made another video on the basics of using tree diagrams, so I'd recommend you watch that one first if you haven't already. Example 1, and this is using a tree diagram. There are only red marbles and green marbles in a bag. There are 6 red marbles and 4 green marbles. Mason takes at random a marble from the bag. He does not put the marble back in the bag. Mason takes at random a second marble from the bag. Part A, complete the probability tree diagram. Now this is really important. He does not put the marble back in the bag. This means we're going to have conditional probability, and the probabilities are going to change on the tree diagram branches. For this question, to help visualize what's going on, you could draw a picture. Say this is the bag. It says Mason has 6 red marbles and 4 green marbles. For the first marble, the probability that he picks a red one is just going to be 6 out of 10 because there are 6 red marbles and 10 in total. Similarly, the probability that he's going to pick a green one will be 4 out of 10. Then for the second marble, second set of branches, it depends on which colour marble he's chosen first. So if we start with him choosing a red marble, take a red one out of the bag, now the probability of choosing a red is going to be 5 out of 9 because there are 5 red marbles left in the bag and 9 in total. In this situation, the probability that he'd pick a green one would be 4 out of 9 because there are still 4 green ones to choose from. He hasn't chosen one yet. And again, there's 9 in total. As a reminder, on probability tree diagrams, the probabilities on any set of branches will always add up to 1. So you can check here, 5/9 and 4/9 do in fact add up to 1. Now let's think about the other scenario where he takes a green marble out first. For the second marble now, the probability of choosing a red is going to be 6 out of 9 because there are 6 red marbles to choose from and 9 in the bag. And the probability of selecting a green one for the second marble is going to be 3 out of 9. You don't have to draw a picture to help you. You could just think about that in your head. That's part A complete. We've now completed the probability tree diagram. So let's look at part B. Work out the probability that Mason takes 2 marbles of the same colour. So to do this, I like to select the pathways on the tree diagram that I'm interested in. So same colour would be red, red, or green, green. Then going across the tree diagram, we multiply the probabilities together. So for red, red, that's going to be 6/10 times 5/9, 30 over 90. And for green, green, we've got 4/10 times 3/9, 12 over 90. Going down the tree diagram then, we add these two probabilities together to get the final answer. So 30 out of 90 plus 12 out of 90 is going to give us 42 out of 90 for the final answer. Example 2, a gym runs 2 fitness classes, spinning and circuits. On Saturday, 100 people visited the gym. 18 people attended the spinning class, 10 people attended both classes, 56 people did not attend either class. Part A, represent this information on a Venn diagram. So let's draw a Venn diagram to represent the information. 2 circles, one for the spinning class and one for the circuits class. Now, when you fill in a Venn diagram, it's always best to start with the overlap if you can. And in this case, we know that 10 people attended both classes, so 10 can go in the middle. We then know that 18 people attended the spinning class, so that means there's going to be an 8 here, so that altogether in the spinning class circle, there are 18 people. We're also told that 56 people did not attend either class, so that can go on the outside of the circles. And then to work out this part, we're just going to take the total number of people, so 100, and subtract all the other parts. When we do this, we get 26. So 26 people just attending the circuits class. And that's it. That's the completed Venn diagram. Let's move on. So a person who attended the gym is selected at random. Find the probability that this person attended only circuits. Only circuits, that's going to be this part here. So that's going to be 26 out of the 100 people. Part C, attended exactly one class. So that will be the 26 people that attended only circuits plus the 8 people here that attended only spinning. So that's 34 people altogether selected out of the 100. So 34 out of 100. And then part D, probability that the person attended spinning given that they attended circuits. Now that's the interesting part. Given that they attended circuits means we're only interested in choosing out of the people that attended circuits, which means that the denominator on our fraction for our probability is going to be 36. It's now going to be out of 36 rather than 100. Now, of those 36 people, how many attended spinning? Well, that will be the 10 people that went to both spinning and circuits. So the final answer is going to be 10 out of 36. I just wanted to point out at this point that you may see this word given represented in probability notation. So you might see something like P, S, and then a line, C. That line means given. So this part in purple would be read as the probability of spinning given circuits. Or you might see it written in words like we had in part D there. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.